Hello guys, so we know in our last video we proved the arithmetic series or the sum of natural numbers using mathematical induction. Now let's prove the geometrical sequence. Now we have 2 plus 2 square plus 2 cube plus dot dot dot. So the first step is let Pn is equals to 2 plus 2 square plus 2 cube dot 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 2n be 2 to n minus 1. Now here let's take P1, which is the first number, which is 2. So this is the left hand side, and the right hand side we have 2, and where n is 1, so 2 to the power 1 minus 1. Now this is just 2 minus 1, which is 1, so 2 into 1 is 2. So there we have 2 equals to 2. So we know this is true. So now let's let pk be true for all k belonging to natural number. So here we have pk going from 2 plus 2 square plus 2 cube plus dot dot up to 2 to the power k, which is equals to 2 into 2 to the power k minus 1. So now what we have to do is prove the next number to k, which we have to prove pk plus 1. So pk plus 1 is 2 plus 2 square plus 2 cube plus dot 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 2 to the power k and then 2 to the power k plus 1, the next number, which should be equals to 2 bracket 2 to the power k plus 1 minus 1. Now we have assumed this to be true. Now let this be equation 1. We can see for pk plus 1 it goes from 2 plus 2 square plus 2 cube up to 2 to the power k, which is the same as equation 1. And here we know that this is equals to 2 into 2 to the power k minus 1. So in the left hand side we can simply put this instead of that. So we have 2 into 2 to the power k minus 1 plus 2 to the power k plus 1. Now let's open the bracket. So 2 to the power k into 2, this is just 2 to the power 1, and we know if the base is same then the power will get added. So 2 to the power k plus 1 minus 2 plus 2 to the power k plus 1. Now we have 2 to the power k plus 1 and 2 to the power k plus 1. So we have 2 to the power k plus 1, 1 plus 1 minus 2, which equals to 2 to the power 2 k plus 1 minus 2. And now what we require is 2 to the power 2 k plus 1 minus 1. So we need to prove this. What we do is we take 2 common, 2 to the power k plus 1 minus 1. This is equals to the right hand side. So hence we have proven that p k plus 1 is true when pk is true. So that means the next number is true when the previous number is true. So that means if every number there is always a previous and a next number. So that means p to the power n is true for all n belonging to natural number. So now we have n cubed plus 2n is divisible by 3. We need to prove that, well, the statement is true. So in the first step we always know to let Pn be n cubed plus 2n. But what's different about this is that this is a logical proof. This is a logical statement. There is no left hand side, right hand side. So we need to prove with just one equation. So let's take P1. We have n cubed plus 2 into 1, which is just 1 plus 2 equals to 3. And obviously 3 is divisible by 3, so this is true. So let pk be true for k belonging to natural number. So we have pk equals to k cubed plus 2 to the power k. So now we have to prove pk plus 1. So pk plus 1 here is just simply k plus 1 cube plus 2 k plus 1. So here what we simply do is let's just open the bracket, which is just a plus b whole cube, which is k cube plus 3k square into 1, so just 3k square plus 3k into 1 square plus 1 plus 2k plus 2. Now let's add these, k cube plus 3k square plus 5k plus 3. Now what we have to do is we need to bring k cube plus 2k somehow into this equation. Now how we do that is we take k cube plus 2k plus, and then we have 3k square plus 2k from 5k, if we minus 2k, we get 3k. So remaining is 3k plus 3. Why did we do this? Because we know that this term is true. So we also need this term as well. We need the help of the first equation anyhow to make sure that the pk plus 1 will be true. So we have k cube plus 2k plus 3, k square plus k plus 1. Now we know that this first term is true because we have assumed it, and now this second term is a multiple of 3. Whatever this may be, it will always be 3 times something, which will always be divisible by 3. So this is also true. Hence, this whole pk plus 1 is true. So that means pk plus 1 is true. True when pk is true. Similarly, Pn will also be true for all n belonging to natural number. So we need to prove n into n plus 1 into n plus 2 is a multiple of 6. So the first step is to relate this equation, n plus 1, n plus 2. Now we have P1, 1 plus 1 into 1 plus 2, which is just 1 into 2 into 3, which is 6, which is true. So now we let PQ be true for k belonging to natural number. So now we have to prove pk plus 1, which is k plus 1, k plus 2, k plus 3. Now we somehow need to bring this into that equation first. Now yes, you can multiply out this, but it will be very long, lengthy, and difficult. So now what I will do is actually rearrange this. Now, as we have learned in 7th or 8th grade, a plus b into c plus d. Yes, we have learned to do it directly now because we're smarter. AC plus AD plus BC plus BD. But how did we get that answer? Well, simply we just separate the terms like this and then multiply out. So similarly, I'm going to do that as well. K into k plus 1 plus 3 into k plus 1 whole multiplied by k plus 2. Now again, you can set this as A and this as B, and this is just one term. So now this is just this multiplied into that plus this multiplied to that, which is, I'm going to write it here, k plus 1 into k plus 2 plus 3 k plus 1 into k plus 2. Now we know that k plus 1 and k plus 2 is true. So now how will we know that the second term is a multiple of 6? K plus 1, k plus 2. Now let's exclude the 3 for now. Let's look at k plus 1, k plus 2. If k is odd, k plus 1 will be even. So that means k plus 1, k plus 2 will also be even. Now if k is even, then k plus 2 will also be even. Then again, k plus 1 into k plus 2 will also be even. So in this case, we have 3 into an even number. Now if we remember a simple trick, then to know whether a number is divisible by 6 or not, we need to know if it is divisible by 3 and also divisible by 2. Divisible by 2 simply means that it's an even number, and we have 3. So 3 into an even number, let's say m. This m is an even number, so it's a multiple of 2. Let's say 2 into p. So we have 3 into 2 into p, we have 6p. So therefore it is a multiple of 6. So we know 3k plus 1, k plus 2 is also a multiple of 6. Hence this pk plus 1 is true. So pk plus 1 is true when pk is true. So therefore that Pn is true when n is a natural number. Thank you.